First, I will introduce myself. I'm Dr. Islam Abdul Maqsood. And we'll study Math 1. Math 1 is divided to two categories. The first category is calculus, or more specifically, differential calculus. And the other category is algebra, and in this branch we will study two subjects, which is matrices and analytical geometry. Today we'll start with the first category, which is calculus, or more specifically differential calculus. What is calculus? Calculus is the study of change. In many applications we will find that there is a relation between some variables. For example, if I had some car in the street, and we'll suppose that its position is x, and I will suppose this point is 0, so this position will be, for example, x. Okay, if the car is moving, so its position is changing with time. So we'll have a relation between x and another variable, which is time. X is the position and t is the time. Okay, now we need to study or to give some specifications of that change. Does that change happens quickly, or does it happen slowly? These are specifications of that change. Studying that change, that is the science that is called calculus. The word calculus comes from calculate. What are you calculating? You are calculating the change, or how to determine the change between some variables. So how will we study that change? As I told you, the change can be a slow change, it can be a fast change. How can we determine or give some number to measure that change? That is what we'll study in calculus. I told you that calculus is the science of studying calculations. What are you calculating? Calculating the change. Okay, so that is the branch of calculus. The branch of calculus is divided into also two subsections, which is differential calculus, and the other is called integral calculus. Integral calculus will be studied in the second term, or in Math 2, integral calculus, and we learn what does it mean. Okay, but now we'll study differential calculus. So first we need to determine what is a relation between two variables. In mathematics, we define a relation between some variables. We call it functions. We have a tool to specify a relation between some variables. We call it functions. How do we express a relation between two variables? We say, for example, that y is equal to f of x. Okay, now this, what is the function here? That is the function. What is a function? A function is an operator. It operates on some input and gives some output, which is that variable. So that is the input and that is the output. Okay, and that is the function f. I want you to know that the only function, when I say a function, I don't express it as f of x. That is the output of the function. That is the output of the, where is the function itself? The function itself is that f only. Okay, so we say here that f is the function. It operates on some input. Operates on some input. We call it, for example, x. Okay, and gives some output which is called, for example, it's called y. Okay. Now, how to specify a given function? How two functions are different? The first specification of the function is how does it operate on the input. For example, I can say that f of x is x cubed. That is a function. What do I mean by that expression? What do I mean by that expression? When I say f of x is x cubed, so when I say f of x is equal x cubed, what do I specify here? I specify how the function operates on a given input. So f operates on some input x in this way. It takes that input and it makes the cubing of that input. Okay? It doesn't matter what is the name of that input. For example, I can say I just need to specify how to operate on some input. For example, I can express the same function as follows. I can say f of z, for example, f of z is z cubed. These two expressions give the same meaning, which is that f operates on some input by cubing that input. Okay, so that is the meaning of that expression. I can say that f of some square is that square cubed. Now, if you understood that, what I mentioned here, if I say, for example, if I had that f of x is equal to x cubed, and I give you some other function g, and I told you that g of y is y cubed. Okay? Now my question is f equal to g or not?
Yeah.
Is that expression true or false? What is your opinion?
I think it's true.
I think it's true.
True. No.
This is true. Why? Because both functions operate on the input in the same way. What is the function? The function, as I told you, it is an operator.
Yeah.
When does two functions when two functions are equal? When two functions are equal, when they operate on the same way on the given input. So what would I determine from these two expressions? How can I specify f and specify g? How can I know that f is equal to g? If they operate on the same way, I need to know the way by which f and g operates on their input. If they have the same way that they operate on the input, so they are equal functions. Okay? So I specified for the first function, I specified that f operates on its input by cubing that input.
Yeah.
And g operates on the input by cubing that input also. So both f and g operate on the same way they operate on the same way on their inputs. Okay, so we learned that for two functions to be equal, they have to operate on the same way on their inputs. Okay, so how to determine the way on which the function operates on the input? By this expression. Okay, so if I told you that f of x is equal to x plus x cubed plus x all squared, what does that mean? It means that f, when it operates on some input x, it will be it takes that input and makes it cubing, then plus the same input, then all squared. Okay? If I told you I want to find f of y this time, f of y, what will be f of y? It will be, it operates on y on the same way. In that expression I just learned how f operates on its input. I just learned how f operates on that input. So whenever I have known this, I can determine this. Because f operates on y on the same way, I just symbolize the input as x. Okay? So it operates, how would it operate on y? Just by taking in the same way, and it will be y cubed plus y all squared. What if I say I want to determine f of x plus y? What would that be? F of x plus y. It will operate on the same way. I just treat that input as a block like this, and I operate f on that input in the same way I have operated on any input. I just told you that f operates on any input in that way. It takes it and makes it cube, then plus the same input and all squared. So whatever was the input, I just operate it on the same way that I have determined in this expression. Okay? So what will be the output of this function? It will be x plus y all cubed plus x plus y, then all squared. Okay? Is that clear? Now, when I say, we have just some terms. When I say y is equal to f of x, that is the function or the operator. The function or the operator. And that is the input. That is the input. And that is the output. Okay? Sometimes we give it some other names. We call the input the independent variable. Independent variable. And we call the output the dependent variable. Because this relation, that determines a relation between x and y. Whenever x changes, y will also change. Whenever x changes, y will also change. So that is some relation between x and y. This is a relation between x and y. That is called an independent variable. What it is meant by independent variable? It means that it can take any value. It can take any allowed value. Okay? But whenever x takes some value, so y will be dependent on that value. So I can change x whatever I want. I can change x whatever I want. Accordingly, y will also change. That's why this is called a dependent variable. It depends on x. It depends on x, and that is called independent variable because it is treated as if it is a free variable. So that's why it is called independent. That's why it is called independent, because it is free. And that's why if I said here, what is f of 5? If I give you this expression, f of x is equal to x cubed plus x all cubed. What is f of 5? 5 cubed plus 5 all squared. Okay? So given the way that f operates on the input in that expression, to find the output of any given input, we just replace x by that input. We just replace x with that input. So I can say if what is f of 5, I just replaced x by 5. If I want f of y, I just replace x by y. If I want to determine f of x plus y, I just replaced x by x plus y, and so on. Okay? Now let's see that example. If given that f of 5x is equal to x squared, then find f of x. If f of 5x is x squared, find f of x. How to determine what is f of x? F of x is the function. I need to determine how f operates on x. What is given in the problem is that how f operates on 5x. That is the way that f operates on 5x. How to determine how f operates on x instead of 5x? We have many methods to know this. First, I just need to find or to express that output in terms of that input. I need to see it as an expression of that input. How would I do that? It is given that f of 5x is equal to x squared. I can look at this as 5x over 5 all squared. I didn't change anything here. But what did I benefit from this expression? I just expressed that output in terms of the input, which is 5x. I can now see 5x here. Okay? So that is just equal to 5x all squared over, when I distribute the power, it will be 5x all squared over 5 squared, which is 5x all squared over 25. So can I determine from this how f operates on x? Now f operates on 5x. F operates on 5x in this way. It takes 5x, then it makes a squaring that divides by 25. So that is the way that f operates on its input. That is the way that f operates on its input. So I can say that f of x will be equal to, it takes that input and makes squaring, then divide by 25. That's one way to determine f of x from f5x. Another way is if I told you that f of 5x is equal to x squared. I need to determine how f operates on the input. So let's name that input. What if I told you that I can name f5x to be, for example, to be y? So I have now, as if it is called a substitution. If y is equal to 5x. So in that way, I will just need to know f of y will be equal to, I need to express that output in terms of the input, which is y now. From this relation, I can substitute x with, x will be in terms of y will be y over 5. It will be y over 5. So that's why that will be y over 5 all squared. And that will be y squared over 25. So what is, if I know now that f of y is equal to y squared over 25, what will be f of x? It will operate on the same way that f operates on y, which is y over 5 all squared, or it will be x squared over 25. Okay? So that's another way to find f of x given f of 5x. Okay? So the first specification of a function is how does it operate on the input. If we have two functions, how to know if they are equal or different? By the way, the first specification is the way that it operates on its input. Okay? What other thing that specifies a function? It is called the domain of a function. Domain of the function. Now, if I told you that y is equal to f of x, we learned that there is some input or some independent variable and some output. Okay? If I told you, for example, that y is equal to root x, could I put any x under the root? Is it allowed to put, for example, root minus 4? Is it allowed to do this? No. In real analysis that we are studying, we're studying here real analysis, so it is not allowed to put a negative number inside the root, the square root. Okay? So this is not an allowed value for x. So now let's specify some terminology here. We say that f can operate on some inputs, some known inputs. Some other inputs are not allowed. These we will contain all the allowed values for x. We will contain it in some set that is called the domain. So what is the domain? The domain is the set of all allowed values of x or of the input. The input is not obligatory to be x. It could be some other name. It is just a variable. So it is not just the input. The set of all values, of all allowed values of the input. Okay? So when I say that y is equal to root x, what is the set of all allowed values of the input? It will be the interval from 0 to infinity. It will be the interval from 0 to infinity of the real numbers. All the positive numbers, all positive numbers with 0. All positive numbers with 0. Okay? So what about the set of all the outputs? The set of all the outputs for all the given inputs is called the range. The range of the function. So what is the range of the function? It is the set of all outputs of the domain. The set of all outputs of the domain, it is called the range. Okay? When I give you this expression, sometimes I can give you an expression called f is from R to R. F is from R to R. That expression, I give you some function, it is called f. What is meant by that expression? So first, what is R? What is R? Do you know what is R? It is the set of all real numbers. All real numbers. So by this expression, this is called the domain. So f is a function. I specify here that the domain is R, which is meant that all real numbers are allowed in this function. What about this R? In this expression, no, this is not the range. In this expression, this is called the codomain. This is called the codomain. A codomain is a set which contains the range. It's a set which contains the range. Knowing specifically the range is not an easy. It is not an easy task. That's why for many functions we just specify the codomain, which is a set, a bigger set. This is called the codomain, which I know that the range will be inside it. A bigger set that I know that the domain will be inside it. Okay. Usually we take the codomain to be the real numbers. Okay. But when I say I need to find, so this that blue set, this is called the range. What is the range? It is the set of all outputs. The set of all outputs is different from the codomain. A codomain is just a bigger set that includes the range. Okay. Does any of you don't know the meaning of that expression? That is called an interval. Is that an open interval or closed interval? Yes, zero closed, and it is semi-closed or semi-open. What is the difference between a closed and open interval? First we have a number line. That is the number line 0, 1, 2, 3 and so on, -1, -2, -3. These are the integer numbers. But when I also include the in-between numbers or the in-between numbers, that is the set of real numbers are. When I need to specify some interval, I can say that I need, for example, from -1 to 2. From -1 to 2. From -1 to 2. The set of all numbers between -1 and 2, this is called the interval from -1 to 2. Okay? In an interval, we always put the smaller number first. I don't say an interval to be 2 and -1, no. We just express it in that way. That interval have 4 options. It might be like this, or it may be like this, or it may be like this, or it may be like this. What is the difference between these 4 expressions? Whatever it is, this is called a closed part of the interval. What it is meant by a closed, this is closed and this is open. A closed, it means that -1 is included in the interval. It means that -1 is included in the interval, and we express that in that diagram by shading -1 like this. So by this shading, we know that -1 is included in the interval. This is the interval. So this interval like this, this is like this, -1 to 2. 2 here is closed or open? It is also closed, so I will just shade it like this. So this is that interval. Now, how many numbers are there from -1 in this interval, from -1 to 2? How many numbers do I have in this interval? Any other opinions?
infinite amount of numbers.
Yes, we have infinite numbers here. I'm not saying some students, when I say how many numbers do I have in this interval, they say -1, 0, -1, 0, 1, and 2. So they say 4 numbers. No. They don't know the difference between integer numbers and real numbers. What is the difference between an interval and a set of integer numbers? There is a difference between this -1, 0, 1, and 2. That is called a set of some integer numbers. That is a set of some integer numbers. But that is an interval. What is an interval? It is a set. It is also a set. But it includes infinite numbers. Infinite numbers which are from all the real numbers from -1 to 2. So we have infinite number of numbers included in this set. Can I say that this interval, can I express it like this? 2 minus 1? No. Why? Why this expression is not correct? In an interval, we need to put the smaller number first. We can't have this is not an allowed expression for an interval. Okay, and so on. If I need to express that interval, we make it like this: from -1 to 2. We have here -1 is closed and 2 is open. So I have all the real numbers from -1 to 2, and -1 is included in that set. Okay. In some textbooks, how to express an open interval, they use the bracket instead of a square bracket like this. They just express it like this: -1 to 2, like this. So sometimes it makes some ambiguity with a point in the Cartesian plane. So we prefer to use this expression for an open interval. This expression is preferred instead of this expression for an open interval. So sometimes if you just read it in some textbook, they sometimes express an interval like this. They express it like this: -1 to 2. With 2 is open, they express the open interval like this. Instead of a square bracket, they just use a usual bracket. Okay? So we learned that a function is determined by or specified by its domain. The domain is the set of all allowed values for the input. Okay? As I've said, if I have y is equal to root x, we have learned that the positive for x, only positive values of x are allowed, plus the 0. Okay? When I have some relation between variables, we express it or represent it graphically in this way. We have two axes, x and y. Okay? So when I give, for example, x is 0, when the input is 0, the output will be 0. If x is 0, the output y will also be 0. So we have this point which is 0 and 0. We just plot it like this: 0 and 0. This is the point 0 and 0. If the input is 1, the output will be also 1. Root 1 is equal to 1, and that gives me the point 1 and 1. So we have here also another point which is 1 and 1. This is another point of the function. If I have x is equal to 4, y will be root 4. What is root 4? Is it 2 root 4 is equal to 2 or plus or minus 2? Root 4 is 2 only, the positive value only, and we'll learn in detail why it is just the positive value only. When I say root of a number, square root of a number, that gives me only one value, which is the positive value. Okay? When I give you some, when I say root 9, that gives me only one value, which is 3, the positive value only. If I need to express the negative value also, I will just say negative root 9, which is minus 3. That is another value. If this has two values, plus or minus, I wouldn't determine or I wouldn't use minus root 9 like this. But because the square root of 9 only has one value, which is positive 3, then if I need to express the negative value, I will just say negative root 9 like this. So y root is equal to root 4, which gives me 2. So I have a function here, or I have a new point here, which is 4 and 2. I have here 4 and 2. And so on. And also, by using a calculator, I can see the in-between points. So these in-between points, using this, I will just represent the function like this. That function is called root of x. That function is called root of x, and we represent it in that way. Okay? Now let's determine what is the domain of that function from the graph. What is the domain? The domain is all the positive numbers. That will be from, what is the domain? The domain of it is the set of all allowed values of x. So when we say we need to determine the domain from that representation, that graphical representation, we look on the x-axis. Which part of the x-axis that has a curve or that have some output? Which part? It is obvious here that it is the positive part like this. So it will be from 0 to infinity. That is the domain of that function. If I say what is the codomain of root x, a codomain is determined by the given who gives the definition of the function, and the codomain is usually R. Codomain is usually R. It is the set of all values of the output R. Okay, the real numbers are. But what is the range? What is the range of the function? It is the set of all possible outputs. The set of all possible outputs. So that will be, we look in the range, we look on the y-axis, which is the axis of the outputs. So we take the part of the y-axis which contains a graph or which contains a curve, so that will be the positive also. So what is the range of root x? It is the range of root x, it will also be from 0 to infinity. That part of the y-axis. Okay? There is a difference between the codomain. Codomain is always given as R. You can look at the codomain as if it is the y-axis, all the y-axis. But when I say I need the range, what is the range? It is the all the outputs, all the possible outputs, which is obvious here to be the positive only values. That is because root x gives an output of a positive value. It doesn't give a negative value. It doesn't give an output that is a negative value. Now, if I give you this function, y is equal to root x, and I told you that x is greater than 4, or make it 1, x greater than 1, and let's remove the equal also. If I give you that expression like this is called an imposed domain. Imposed domain. That domain that is called the natural domain. Natural domain of the function. Natural domain of the function, which I don't give any restriction. That is just we consider here just the restrictions of the function itself. But sometimes I define a function with some imposed restrictions that I put. I say here that x is greater than 1. That is an imposed domain. That's my definition of a sum function. Okay? So how to give a graph of this function? In this function, is it allowed to put, what is the domain of this function? It is, yes, from 1 to infinity. 1 is open or closed? It is open, like this. So, in this function, for this f of x, can I find f of 0? What is f of 0? For this function, this for f of 0 for this function is undefined. So I can determine f of 0 here. I can say here that root 0 no is equal to 0. No, this is not a correct answer. Why? Because for this function I imposed some domain. I put a restriction in my definition of the function. I put here that x is greater than 1. So don't go out of this imposed domain that I gave you. Okay? So for this function, what is the domain of this function? It starts from 1. When I give a graph of it, it will be just like this. So for this function, what is the domain? We have just said it is the interval from 1 to infinity. And we have here 1 is open. 1 is open. What about the range? What about the range of this function? We look on the y-axis, which part of the y-axis that has a curve. At this point, this is 1. What is the output of this? It will be also 1. So what is the range of this function? It is that part of the y-axis, which will be also from 1 to infinity. Okay? So I've known here the difference between a natural domain and an imposed domain. Sometimes we impose some domain like this. When I say the domain, I need to find the domain of some function. What is meant by this? An imposed domain or a natural domain? A natural domain. When I tell you, given that function, find the domain. When I tell you find the domain, it is meant to find the natural domain of the function. Okay? So it is any domain, it is the natural domain unless I specified that is not. There is something called, or there is some condition of a function. Condition of function. There is a rule on a function which states that every element in the domain must have only one output, only one image or only one output. So if I give you this function and I told you that x gives me some two values, if I give you that 1 gives me 3 and 5, is that a function? No. That may be called a relation. That may be called a relation between that input and output. But this is not a function. This is not a function. Why? Because for a function is a simple form of a relation. A function is a simple form of a relation. So what is the simplicity in that relation? That every element in the domain has only one output. I can't have more than one output for a given input. Okay? What about this function? If I have that input 1 and that input 5, both of them give the same value, which is 6, for example. Is that a function or not? Yes, that is a function. It is not, there is no problem if I have two values in the input give the same output. No problem in this. It will just be a function as it is. As long as every input has one output. That input 1 has only one output, which is 6. And that also, that output, that input 5 has only one output, which is 6. So there is an important condition of a function that it has every element in the domain has only one output. Has only one output of in the range. That condition is represented graphically by the vertical line test. Vertical line test. What is the vertical line test? We say a function is represented as a curve by putting the inputs with the outputs in a point, and we collect all these points of the inputs and outputs like this. That represents a function. Now, can I say that this curve represents a function or not? No. Why? Because there are some inputs. For some inputs, I have more than one output. That is an output, and that also is an output. So that is not a function. That is not a function. When I say function, I give this notation sometimes. That is just meant to be a function. Okay? So we have here a test. It is called a vertical line test. What is a vertical line test? It is that we take a vertical line, and whenever I find more than one intersection with the curve for any vertical line, whenever I find just one line, if I just find one vertical line with more than one intersection, then that immediately is not a function. So what about this? Is that a function or a relation? That is a function. Why? Because any vertical line, if I imagine any vertical line, I will just have one intersection. I can't have more than one intersection. Whenever I have more than one intersection, then it is not a function. If I say, for example, y squared is equal to x, when I give a graph of this function, it is like this. Or if I give a graph of this relation, it is graphed like this. So what do you think here? That is a function or not? That is not a function. Why not a function? Because we have a vertical line. For the vertical line test, we have here more than one intersection. So whenever I find any vertical line with more than one intersection, then that is not a function. If I have a function like this, that is function or not a function? Not a function. Why? Not function. Why? although any vertical line here gives one intersection, but there is one vertical line. There is one vertical line which gives me two intersections. So that's why it is here, it is not a function. What it is called in mathematics, it is called a relation. Any function is a relation, but a specified kind of a relation, it is called a function. What is the condition of the function? It a function which satisfies the vertical line test, or every input in the domain has only one out. We need to find to know some known classifications of functions. Known classifications of functions. There is a function called, an elementary function called power function. What is a power function? Power function is expressed like this: y is equal to x f of x, which is x power n. So the function that is expressed as x power n, that is called a power function. Okay, that is called a power function. So for example, for n equals 0, the power function will be x power 0. What is x power 0? It is 1. So that is called the constant function. The constant function 1. The constant function 1. For n equal 1. N equal 1. That will be y is equal to x power 1. Y is equal to x, that is a straight line. That is a straight line which goes through the origin like this. That is x. Y is equal to x is just expressed in this way. Okay? Y is equal to x. If n is equal to 2, so we'll have here y is equal to x squared. X squared has a graph like this. Now remember, you have to memorize all these elementary functions. You have to memorize all of these. If I have n is equal to 3, which is y is equal to x cubed. Y is equal to x cubed. The graph of this function is known to be like this. And it goes down like this, and that goes up like this. Okay? What about n is equal to 4? N is equal to 4, which is x power 4. The graph of x power 4 is just like the graph of x squared, but it is just thinner like this. Why? Because when I say, for example, 2, if I have a number 2, the output will be 4 in this function. But for this function, the output will be 2 power 4, which is 16. For the same input 2, it will be 16 instead of 4. So it will just be thinner like this. So we can find a pattern here that for n even greater than 0, excluding the 0, for even numbers like this, we'll have that is x squared, that is x power 4, and we find that is x cubed, x power 6, and so on. And so on. Okay, so these power functions for even integer powers like this. What about for the odd? For the odd, it starts by x equals 1 like this, but starting from 3, it will just have the same the same form as x cubed like this. So that is x cubed. That is x cubed. For x power 5, it will just be thinner like this. So that is x power 5. And so on. We'll have here that is x power 7. X power 7 and so on. Okay? So I've learned how to graph power functions for integer positive numbers of n. What about negative numbers for n? Negative powers. What if I say n is equal to -1? So the function would be, or the power function would be x power -1. X power -1. That is just 1 over x. Do any of you how to graph 1 over x? That function is like this. So that is 1 over x. Remember, you have to memorize these expressions or these graphs. Okay, that is 1 over x. What about n is equal to -2? N equal to -2. For n equal to -2, that is y is equal to x power -2, which is 1 over x squared. The difference between these two, it is that all the negative values will be squared. What happens if a negative value is squared? It will be positive or negative? It will be positive. When a negative value is squared, the output will be, so this expression is just 1 over x all squared. So you are just making the squaring of this graph. The squaring of this graph, it will be thinner like this. It will be just thinner like this in this part. It will be thinner like this. But for the negative part, it will be, instead of being in the negative, the output will be negative. It will be just be positive. So it will be thinner and positive like this. Okay, so that is for n equal to -2. What about n equal to -3? N equal to -3. That will be 1 over x all power 3, or which is 1 over x all power 3. That is for an odd power, it will just be like 1 over x, but with thinner or more compressed like this. It will be just more compressed like this, and so on. If I need to find 1 over x power 5, it will be just thinner or more compressed like this, and so on. If I need to find 1 over x power 4 for n equals -4, that will be just like this but thinner like this. Okay, so these are the power functions. So we learned how to find power, or how to graph power functions for positive or negative integer powers. Can I have the powers to be fractions? Yes. If I have, for example, n is equal to half, that is x power half. What is x power half? It is root x. And we learned how to graph root x, which was like, it was like this. Root x is just like this. Okay? Now, let's look at the domain and range of all of these functions. The domain in this function is R. What about the range of this function? What are the output, the set of all outputs of this function? The domain is R, all R. And this is obvious from the x-axis. What about the y-axis? What are the values of the y-axis? It is just 1. So the range is just the set 1. The range is just the set 1. What about this function? The domain is R and the range is also R. For this function, the domain is the domain is R. Why? Any value of x, when I need to find the domain, I just look on the x-axis. What part of the x-axis that has a curve? So it is obvious here that all of the value of the x has a curve. So the domain is R. What about the range? The range is from 0 to infinity. That is the range. From 0 to infinity. And so on. For this, the domain is R and the range is R. Okay? What about this function? The domain is R, all R, instead of some value. Instead of 0, yes. So we express it like this. Instead or minus the set 0. What about the range? Look at the y-axis. It is, the range will be R also excluding the 0. R excluding the 0. Now for this function, the domain is all R instead of excluding 0. What about the range? It is, yes, R positive, or the interval from 0 to infinity. Is 0 included? Can I say 0 is closed 0? No, because I don't have an input that gives me the output 0. All of these, this is called an asymptote. Asymptote, it means that this is called an asymptote of the function. It never gives or it never intersects with this axis or the asymptote. There is another kind of a function which is called polynomials. A polynomial, it is a linear combination of power functions with non-negative powers or non-fraction powers. Or we say a linear combination of power functions with positive integer powers or 0. What is meant by that? A polynomial. What is meant first? What is meant by linear combination? Linear combination in mathematics is a very important concept. A linear combination, it means it is to multiply by some scalar and make addition or subtraction. For example, if I have some element as a triangle like this and another which is this rectangle. A linear combination between these two elements is to say, for example, 3 triangle plus 5 of the rectangle. That is called a linear combination. If I say 5 triangle minus 7 rectangle, that is called a linear combination. But if I say 5 triangle squared minus 4 of the rectangle, is that a linear combination? No, that is not a linear combination because we have here a power 2. So what is a linear combination? It means just to multiply by some constant and to make addition or subtraction between these elements. Okay, if I have a triangle and a rectangle and a circle, a linear combination between these three is, for example, 3 triangle minus 5 rectangle plus 7 circle. That is called a linear combination of these three elements. Okay, so when I say what is a polynomial, it is a linear combination of power functions with positive integer powers or 0. So a polynomial, if I give, for example, 5x power 7 minus 3x squared plus 1, is that a polynomial? Yes, it is a polynomial, because here we have 5x power 7 minus 3x squared plus 1. Here are power functions. These are power functions with positive integer powers, and this is a linear combination between them, so this is called a polynomial. This is called a polynomial. But if I say, for example, 5x squared minus 1 over x, is that a polynomial or not? That is not a polynomial. Why? Because here we have a negative power. This term has a negative power, 5x squared minus x power minus 1, and negative powers are not allowed in a polynomial. Also, if I have, for example, 7x minus root x, is that a polynomial or not? No, that is not a polynomial. Why? Because we have a root, that is a fractional power, x power half. That is x power half. We also have another definition, which is a rational function. A rational function is a quotient between, or the ratio between two polynomials, p of x and q of x. If I have some polynomial over some polynomial, so that is called a rational function. X squared, for example, plus 1 over x cubed plus x plus 2. This is called a rational function. It is a ratio between two polynomials. Okay? Now, the first kind of problems that we will study is to find the domain of a given function. To find the domain of a given function. If f of x is root of something, what is the condition to know the domain of that function? It is that what is inside the rule must be greater than or equal to 0. Okay? If I have 1 over some expression, what is the condition for this to be allowed? That is not equal to 0. If I have 1 over root of something, that will be, what is the condition to find the domain? It is greater than 0. I will just exclude the 0. Why? Because I can't put this expression to be 0, because it is in the denominator. 0 in the denominator is not allowed. So, for example, if I had f of x is equal to 5 over x minus 2, what is the domain of this function? We need to find the exclusions of this expression. I have here a denominator, so it is not allowed to put x is minus 2 equal to 0, which is x equal to, that is the excluded value. So we say here that the domain is r excluding 2. R excluding 2. If I say f of x is equal to root x plus 3, what is the domain of this function? Yes, we take what is inside the root and put it inside this inequality, x plus 3 greater than or equal to 0. Greater than or equal to 0. that gives me when I solve this inequality. I need to know how to solve an equality like this. This will be, I'll just put it in the other side, that will be greater than -3. This is expressed as on the number line from -3, and it is closed. Greater than -3, we have all this interval, which is the interval from -3 closed to infinity like this. So that is the domain of this function. That is the domain of this function. What about this expression? F of x is equal to 2x minus 3 over x squared plus 4. Whenever I have a denominator, we exclude the values, the zeros of the denominator. Okay, we exclude the values of the denominator, the zeros of the denominator. When is x squared plus 4 equal to 0? We don't have any values for which x squared plus 4 is equal to 0. So that is never 0. Never 0. So what is the domain of this function? It is all R. There are no exclusions. Why? Because the solution of this equation is phi. The solution of this equation is phi. It has no solution. No solution. Now if I say I need to find the domain of this function, 2x minus 7 over root x plus 3. I need to find the domain of this function. Now the root is in the denominator. So in this case, we will say what is inside the root. What is the domain? The domain satisfies that x plus 3 will be greater than 3. And I solve this inequality. I need to remember that any problem to find the domain, we just transform or convert the problem of the domain to be a problem of solving an inequality. This is the first step, to convert the problem of finding the domain to a problem of finding, this is 0, to a problem of solving an inequality. So that is x greater than minus 3. So the domain in this case will be from minus 3 open to infinity. Infinity will always have an open interval because infinity is not a number. What about if I say this function f of x is equal to root x minus 4 over x squared minus 25. For this function we have two restrictions. One is from the root and one is from the denominator. And we need both restrictions to be applied at the same time. We express that as an intersection. An intersection between two conditions. We say here and. The two conditions must be satisfied at the same time. The first condition or the first restriction comes from the root, which says that I need to satisfy that x minus 4 is greater than or equal to 0. The second restriction is I need that x squared minus 25 is not equal to 0. So these are the two conditions that I need to be satisfied simultaneously. At the same time, we need these two conditions to be satisfied. And I need to find the solution of these two restrictions at the same time. That will give me x greater than or equal to 4. And this is expressed in the number line from 4 closed like this. I will intersect it with x squared minus 25, that is x squared not equal to 25, which means x is not equal to 5 plus or minus 5. X is not equal to plus or minus 5. That is in the number line, all the number line instead excluding all the number line excluding 5 and negative 5. Now we need to find the intersection of these two. The intersection of these two. This is from 4 to infinity, and we exclude 5 and negative 5. We exclude 5 and negative 5. So we'll exclude 5 and negative 5 like this. This is 5 and this is negative 5. Negative 5 is already outside the considered domain, but only 5, positive 5, is considered inside this part of the domain. So what will be the domain of this function? It will be the interval from 4 to infinity, but with excluding 5 on. I don't say excluding negative 5 and 5, no, just exclude 5, because 5 is the only number in consideration in this case. What if I have this function? I need to find the domain of this function. How to find the domain of this function? We first convert the problem of the domain to be an inequality problem. That is the first step. So this to find the domain is by expressing the restriction, which is x squared plus 3x minus 25 greater than or equal to 0. Now how to solve this inequality? Now this inequality is just a bit more complicated than an equality like this, for example. That was easy, but that was a second degree. That is a second degree inequality. How to find the solution of this kind of inequality? Now, if I have any inequality with some rational function greater than or equal to 0, this part of 0, we just have the same procedure to find the solution of this inequality. If I have a polynomial, put it in brackets like these, we will learn how to find the solution of this inequality. How to find the solution? We have known steps. Now what we will learn now is the procedure to find the solution of some expression. For example, x minus 3 times x plus 1 all over x minus 1 greater than 0. This must be 0. The right hand side must be 0. That it can be greater than 0 or less than or 0. But this side must be 0. The first step, that this side must be 0. For that side, it's better to be expressed as the multiplication and division of some brackets like this. Okay? So for a problem like this, first we'll factorize that expression. When you factorize this expression, we'll just find it x plus 7 times x minus 4 greater than or equal to 0. The first step is to determine the zeros and the poles of that expression. What are the zeros? The zeros are the values of x which make the expression to be equal to 0. What are the zeros of this expression? It is negative 7 and 4. Negative 7 makes that bracket to be equal to 0, and 4 makes that bracket equal to 0. What about the poles? What are the poles? The poles are the values that make the expression equal to infinity instead of 0. Or in other words, the poles are the values of x that make the denominator to be equal to 0. So for example, for this expression, what are the poles of this expression? It is 1. What are the poles of this of a rational function? They are the values of x that make the denominator equal to 0. So the values which make the denominator equal to 0 are called the poles. The values that make the numerator equal to 0 are called the zeros. We make a difference between these two expressions. So what are the poles of this? We have no poles because the denominator is just 1. It will never be 0. So we have no poles in this expression. Okay? So how to solve that inequality? We put the values of the zeros and the poles on the number line. So we'll have here negative 7 and 4. Negative 7 and 4. These are the zeros. For this expression, for example, we'll put 3. What are the zeros of this expression? What are the zeros in this expression? Negative 1 and 3. So we'll put negative 1 and 1 and 3. Okay, we'll put all of these on the number line. The next step is to look if we have an equal sign or not. If we have an equal sign, we will shade the zeros only. Poles are never shaded. Poles are never shaded. Okay? So we shade negatives. If we have an equal sign, we will shade negative 7 and 4. In this expression, which numbers would I shade? I will just shade negative 1 and 3. We shade only the zeros, not the poles. Poles are never shaded. Poles are never shaded. So we'll shade negative 1 and also shade 3. Okay? So the first step to solve an inequality in the standard expression, which the right side is 0, the first step is to find the poles and zeros. Second step is to shade the zeros only if I have an equal sign. If I don't have an equal sign, what about if I don't have an equal sign? We will not shade any of the poles or the zeros. Okay? Now the next step. What is the next step? The next step is to determine the sign of the in-between values. How would I do that? We will just take a random number, an easy number between these expressions. For example, if I take here 5, we just choose a number in these expressions. Now, if I put 5, if I put 5 in this expression, 5, that 5 minus 4 will give me a positive number. 5 plus 7 will give me a positive number. Positive times positive will be positive. So that part will just be positive like this. In this interval, we have an easy number which is 0. So let's choose 0. 0. Putting 0 in this expression will give me 0 will give me negative. Negative. What about 0 in this bracket? It will give me a positive. Positive times negative will give me negative. So that will be negative in this interval. What about this interval? We choose, for example, negative 8. We choose negative 8, for example. That bracket, negative 8, negative 4 will give me a negative or a positive. It will be negative. Negative 8, negative 4 will give me a negative. What about this bracket? Negative 8 plus 7 will give me a negative value also. So negative times negative will give me a positive value. So that will be positive like this. Now let's represent the solution of the inequality. Let's represent the solution of the inequality. We need that expression to be greater than or equal to 0. So we look at the parts of the number line for which there is a positive sign. So what is the solution of this inequality? It will be this or this. So the solution of the inequality, which is exactly the domain of the problem, it will be the interval from negative infinity to negative 7, open or closed? 7. It is shaded, yes, it is shaded, so it will be closed. It will be closed. Union with the other interval, which is from 4 to infinity, 4 closed like this. So this is the domain of the problem. We can express it or give it another expression. We can say that this is R excluding. Which interval should I exclude from R to express the same set? Yes, from negative 7 to 4. Open or closed? Open, yes. This time will be open. Because if I make it closed, I will exclude minus 7 and 4. And I need minus 7 and 4 to be with me inside the domain. Okay? So, for example, for this problem, if I need to find the solution of this inequality, we just found the zeros and the poles, and we have shaded the zeros and no poles, and the poles are never shaded. Poles are never shaded. Then the next step is to find the signs for the in-between. How would I do that? Just by taking, for example, here 4, and every bracket I will find the sign of each bracket. So if I substitute 4 for this, it will give me a positive value. 4 minus 3, it will give me a positive value. 4 minus 1 will give me a positive value. Positive times positive divided by a positive will give me a positive. So that will be positive. From 1 to 3, I choose, for example, 2. So let's choose 2. 2 plus 1 will give me a positive. 2 minus 3 will give me negative. 2 minus 1 will give me positive. Positive times negative divided by positive will give me negative. Then I choose a number, in this will be 0, for example. So that will be positive. Negative over negative, that will be positive. Then negative 2, for example, I choose here negative 2. That will give me a negative. Negative 2 minus plus 1 will give me negative. Negative 2, negative 3 will give me also negative. Negative 2 minus 1 will give me also negative. Negative times negative divided by negative will give me a negative sign, so that will be negative. Now, if I need to express the solution of this inequality, will be, I need I need to find when it will be greater than or equal to 0. I will just look for the positive signs. So that will be this union with this. So the domain of this expression, or the domain of this expression, or if I say that the solution of this inequality, it is more accurate to say the solution of this inequality. And that inequality came from another problem of a domain, but we are considering here the solution of the inequality. How to solve this, the inequality like this? It will be -1 to 1 open union with 3 to infinity, like this. That is the solution of the inequality. Remember, there is a difference between the problem itself, the domain of the problem itself, and the solution of an inequality. The problem itself is like this. Find the domain of this function. So I have taken what is inside the root, and I put it greater than or equal to 0. Then I put it greater than or equal to 0. When I put this, I learned how to solve an inequality. So what we have learned now is to find the solution of, or what is the procedure to find the solution of an inequality. I need you at home to find the domain of this expression. And determine the domain of this and the domain of this. Find the domain of these two and find the difference between these two expressions. I will just give you a hint for the difference between these two problems. For this problem, we have this root. So to find the domain, I will convert it to take what is inside the root and make it greater than or equal to 0. So x minus 2 over x plus 3, x plus 1. Then I will solve the inequality. Right. Then I will solve the inequality. But for this problem, what will I do? This problem we have two restrictions. One from this root and one from that other root. The first root will give me x minus 2 greater than or equal to 0. And our intersection, the second root, what restriction will give? I will get from the second root. It will give me that x plus 3 times x plus 1 greater than 0 or greater than or equal to 0. Only greater than. I will not put an equal sign because that root is in the denominator. So I find the solution of this and the solution of this inequalities, then I find the intersection between both. When you study this problem and this problem, you will find different domains. So you will learn that making simplifications, algebraic simplifications, change the domain. So whenever I give you a function to find its domain, you can't make any simplifications in the function before you find the domain. This is an important rule. Do not make simplifications before finding the domain, because making simplifications changes the domain. Okay? So that's enough for